Hello YouTube. So today we'll be doing a geometry problem. This is from 12122 Team 9. And so this is one of the later problems in the team round, so you'll expect it to be more difficult than usual. So in this problem, right, we have an isosceles right triangle ABC. So that's a 45, 45, 90. It has a right angle at B, and side BC has length 1, as you can see. And so you have point X such that this angle in blue is equal to this angle in green. And so you have these two angles are equal, and now it's basically asking you to find the length of XC. So how do we do this? Anything, you'll know that this problem hinges on the fact that these two angles are equal, right? That basically defines where X is. It's the fact that these two angles are equal. And so if these two angles are equal, that means this line XC cuts angle ACB in half. And so we can say that it bisects angle ACB. So what can we use about this fact, right? Why is this helpful? Well, if I can just draw, right, any angle, let's draw it vertically, right? And then we can just draw its angle bisector, right? Well, first thing, right, is if you draw something perpendicular to it, right, then you'll get an isosceles triangle. You get these two pieces that are divided by this angle bisector are equal to each other. Something more useful, right, is that you can also do something like dropping the height, right? So if I try to take any point and drop the height, the perpendicular to the other side, what do I get? Well, I get a right triangle. But if I also drop the one to the other side, it's also a right angle. But more importantly, these two are equal. Basically, any point on this line is equidistant, has equal distance to the other two sides. So we can do the same thing here, right? We have X, we can drop the height to side BC, and well, I mean, that's just XB. And then we can also drop the height to side AC. And so we know that these two are equal, right? And just by the virtue of how this is, then we know that this is also equal because these two are the same triangle with the same sides. So then, well, we know BC is 1, so we know that this is 1. Okay, then, so now what? Well, now we can see something kind of easy, right? This is a right angle, this is a 45, right? Since this is a 45, 45, 90. So then what is this? Then this has to be equal to that since we have another 45, 45, 90, right? This AX, let's call this D. AXD is also 45, 45, 90. So that means that, let's just call it X, right? We have this is X, this is X, this is X, right? And then so now what do we want, right? Well, in an isosceles right triangle, it's a 1, 1 root 2 if you know your side length. So that means AC is root 2. So we have that 1 plus X is equal to the square root of 2. Well, we can just solve this. X is equal to the square root of 2 minus 1. And so what do we have? This is equal to the square root of 2 minus 1. And so now this is just very simple at this point, right? You can use the Pythagorean theorem. XC squared is equal to 1 squared plus root 2 minus 1 squared. And now from here, it's just algebra. That's 1 plus 3 minus 2 root 2. Is equal to 4 minus 2 root 2. And now we found basically the side length XC, right? If we wanted to, we should square root both sides and get the side length of XC. But let's take a look at what we want, right? We want the square of the length of XC right here. It can be expressed as M minus root N, right? So, well, we already have a side length squared, M minus root N. So let's just transform this, right? We can just transform this into 4 minus what's 2 root 2? Well, that's just root 8, right? And now the sum of M and N, that's just 4 plus 8 is equal to 12. And that's what we have. So let's recap what we just did, right? We found this problem, right? It's like, well, we don't really know much, right? If we just take a look at this, you have a single fact that these two angles are equal. And that's all we know. But we can use this fact to extrapolate, to basically draw our imaginary lines and get some useful information. In this case, it was just that these two are equal. And that's basically what you want to do when you're finding these problems, like these angle bisector problems, is what more information, like from an angle bisector, you know these two are equal, but what more can we get from it? Here, we got that if you draw the heights, you have that these two are always equal. And that's just a very useful fact in general. And here, it basically allowed us to completely solve the problem. And so that's basically mostly what you can do with angle bisectors.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.